In day 2, you're going to learn about independent and dependent events when it comes to probability. Now, these have slightly different meanings than what you learned in Unit 5-6. Independent events are when the first event does not affect the second event. If I spin a spinner, that has no impact on the spinner spinning again. If I pick a card out of a deck of cards, that has no impact on me rolling a die. They are independent. One has nothing to do with the other. So when you see those, we multiply the probabilities. It's written in math, the probability of A and B happening is the probability of A times the probability of B. So I would say total A and total B, and what we want for the A's and what we want for the B, and you multiply them. Now we're going to take a look at some problems. Most of these things are going to be written as word problems, but get that word problem phobia out of your head. It's just called real-world application. So you have a spinner, has 10 equally sized sections. 8 are gray, 2 are blue. So I'm going to underline 8 gray, 2 blue. I'm going to underline the important parts. The spinner is spun twice. So what's the probability that the first spin lands on gray and the second spin lands on blue? Now I've got a question. Does the first spin have any impact on the second spin? Right, it does not. The first spin has nothing to do with the second spin. So probability A, we want gray out of total is 8 gray out of 10, reduce it, 4/5. Probability B is blue out of total, I ran out of room, equals 2 out of 10, which is 1 out of 5. Now you multiply them. Do not add them. Multiply them. 4/5 times 1/5 equals 4/25. There is a 4 out of 25 chance that you will first land on a gray and then land on a blue. And if you wanted to do decimals, that would be 0.16, just in case you wanted to do it. So we first find the probability of the A event, then we find the probability of the B event, and then we multiply them. Because these two things have nothing to do with each other. They do not influence each other at all. Let's do another one. A student ran out of time on a multiple choice exam and randomly guessed the answers for 2 problems. Each problem had 5 answer choices and only 1 correct answer. What is the probability that she answered neither of the problems correctly? All right, this one you've got to think about. It's kind of why I like it. Probability A is the first problem. There are 5 choices. And actually, let me do the words again, because I think it's easier for you to understand. You are looking for, there we go, wrong answers out of total choices. If only 1 is right, that means 4 are wrong out of 5 possible choices. Let that sink in for a minute. If we say only one choice out of 5 is correct, that means 4 is wrong, and we were looking for the probability she answers neither, okay? Probability B, same thing. Wrong over total 4 wrong out of 5. Now what do? You've got your two probabilities. Multiply them. Do not add them. You have a 4 over 25, 4 over 25. Jumping ahead, guys. 4 over 5 chance times a 4 over 5 chance equals a 16 over 25 chance of being wrong. So you just calculated it. All right, so if you have a multiple choice exam, let's think about this in words. I want you to listen. You have a multiple choice question. It has 5 possibilities. You can eliminate 2. You know 2 of those 5 are definitely wrong. You had a 1 out of 3 chance of guessing the right one. This is probability in action. Now we're going to look at dependent events. Dependent events mean the first event does affect the second event. For instance, picking a card out of a deck and not putting it back. Picking a marble out of a bag and not putting it back. That means you still do the probability, but you get want A over total A times want B over total B minus, usually minus 1. So if I have 10 marbles in a bag and I choose 1 and don't put it back, there are 9 marbles left. Let's look at the examples. You've got 8 people fishing at Lake Connor. 8 people. 5 have licenses, 3 do not. An inspector chooses 2 of the people at random. What's the probability that both have licenses? Okay, so probability A. License over people. How many have licenses? 5 out of 8 people have licenses. All right, now in probability B, we assume it's license minus 1 over people minus 1, because the inspector already chose one person, and we make the assumption that the person has a license. That's what you do with probability. We assume that when the first person is chosen, that first person meets the requirement. So this would be 5 minus 1 over 8 minus 1, 4 over 7. Because once the inspector chooses the first person, there are 7 people left in the group, 4 of which have licenses. So now the probability that both will have licenses, you multiply them. You still multiply them. That does not change. 5 over 8 times 4 over 7 equals 20 over 56. And I'm going to reduce by 4 to make it 5 over 14. Okay, you're going to reduce your fractions. You need to reduce your fractions. It's a skill you need to have. All right, let's do the last one. And we'll play around with this a bit in class. I promise. Okay, I guess I'll do green again. You got a small class, has 9 students, 5 are girls, 4 are boys. The teacher is going to choose 2 at random. What is the probability she will choose 2 boys? So, we'll use big notes over here. Probability of A, boys over total, The first probability is easy. There are 4 boys out of 9. That's easy. Now she's chosen one student. We assume she chooses a boy. That's how the probabilities work. So probability B is boys minus 1 over total minus 1, which is 3 boys over 8 students. So now you do what I've been saying, multiply them. And you get 4 over 9 times 3 over 8 equals 12 over 72, which equals 1 over 6. Okay, let's go to the next page. All right, this is practice. Now, some will be independent and some will be dependent. You need to read the words. I want you to do all of them and then come back and check the notes. I will do them in the recording, but I want you to stop and try. Okay, got a box with 5 plain pencils and 7 pens. Second box has 6 colored pencils and 2 crayons. 1 item from each is chosen at random. What's the probability that a plain pencil in the first box and a colored pencil from the second box are selected? So first, is it independent or dependent? Independent. 2 different boxes. All right, so I'm going to do PA. I'm looking for a plain pencil in the first box, 5 plain pencils out of 12 items. PB, the second box, I'm looking for a colored pencil. There are 6 colored pencils out of 8 out of 8 items. I'm going to reduce that because it makes my simplifying easier later. 3 over 4. 5 over 12 times 3 over 4 equals 15 over 48. I can reduce that by 3. 5 over 16. There's a 5 out of 16 chance that the teacher will pull first a plain pencil from the first box and then a colored pencil from the second box. All right. Let's go to the next one. Again, I want you to try these. Radio Disc Jockey has 7 songs on the playlist. 3 rock, 2 reggae, 2 country. That's a heck of a radio station. The disc jockey randomly chooses the first song, randomly chooses the second one. From the remaining ones. This is a key phrase. Whoops. From the remaining ones means dependent. Because once you play a song, you cannot unplay it. It's out of the list. It's played. So from the remaining ones is a very key phrase. What's the probability that first is reggae and second is rock? Probability A. There are 2 reggae songs out of 7 total songs. Probability B. Well, she played a reggae song first. We didn't lose any rock songs. So there are 3 rock songs still left, but she played 1 song, so it's 7 minus 1. 3 over 6 songs are left. I'm going to reduce that probability 1 over 2. My arrows are terrible. I'm going to multiply 2 over 7 times 1 over 2 equals 2 over 14, which goes to 1 over 7. There is a 1 out of 7 probability that she will play first a reggae song and then a rock song. The key phrase here would be She chooses the second song from the remaining ones. That lets you know that one is used up. That lets you know that the first probability does affect the second probability. All right, let's do another one. Math class. 5 girls and 5 boys in the 7th grade. 3 girls and 7 boys in the 8th grade. The teacher randomly selects a 7th grader and an 8th grader from the class for a competition. What's the probability the students she selects are both girls? Probability A. How many 7th graders are there? There are 10. How many girls? There are 5. Reduce that to 1 over 2. Probability B. How many 8th graders are there? There are 10. How many girls? 3. Oh, I forgot to ask. Is this independent or dependent? It's a little tricky. She's choosing a 7th grader and she's choosing an 8th grader. So choosing a 7th grader has no impact on the number of 8th graders that are left. So this is independent. So you have 1 over 2 times 3 over 10, which is 3 over 20. You have she has a 3 out of 20 chance that both students she chooses will be girls. Now, she has a decent chance of choosing a girl from the 7th grade. She has a 1 out of 2. Half the kids are girls. Last practice. Another radio disc jockey. 8 songs. 3 rock, 3 reggae, 2 country. I really want to find this station. It's a very interesting playlist. The disc jockey chooses, you've seen this before, a song from the remaining ones. There's a key phrase. Dependent. What's the probability both are reggae songs? This is dependent because choosing one, playing one song means there are less songs left. Probability A. How many total songs are there? 8. How many are reggae? 3. The second probability. How many songs are left? 8 minus 1, because they played one song. How many reggae songs are left? 3 minus 1, because both songs need to be reggae. You're left with 2 over 7. So probability A, 3 out of 8 chance of choosing the first song to be reggae. Probability B, a 2 out of 7 chance. Put them together and you get 3 over 8 times 2 over 7 equals 6 over 56. Divide by 2 and you get 3 out of 28. So probability is not that difficult. Look for keywords. Key phrases, I should say. Key phrases. Key phrases. Without returning. Remaining. Without replacement. These are all key phrases for D. Make sure you read the words carefully. The math is not hard, but it's important you choose independent or dependent probability. All right, guys.